What makes planets brighter than stars? How bravely the moon, outnumbered by the stars, shines on her flesh. Every time I look up into the night sky, this lovely line by Angie Wyland makes me wonder and make me doubt myself. When I gaze up at the sky, I see a lot of stars, some of which are comparatively faint to be seen with the naked eye and others of which are much brighter. When our moon is at its brightest, the sky is sufficiently illuminated for me to read a book. Why do certain things have light while others have darkness? Why does the moon appear to shine more brightly than other celestial bodies? Is that thing a satellite, a planet, a star, or what? How come stars appear brighter than planets? What distinguishes a planet from a star, and what elements influence a planet's and a star's brightness? We're going to discuss our ideas on this perplexing subject with you today so that you can recognize a star from a planet the next time you look up at the sky. You wouldn't be surprised to learn that Venus, just after the Moon and the International Space Station, ISS, is the third brightest object in the night sky. Let's talk further about the distinction between a planet and a star before moving on to other issues. A star is a substantial, bright object made of gases like helium and hydrogen. Nuclear fusion, a complex process by which stars produce their own light by converting hydrogen to helium, produces enormous amounts of heat and light that illuminate the area around them. In contrast, planets are enormous stony objects with a gaseous atmosphere. With the stars' leftover stuff in space, planets are created. They lack their own light and are typically encountered in the vicinity of stars. Even though they can reflect light from their parent stars or other cosmic sources, they nonetheless shine brighter than other stars whose light can be seen by Earth. Our solar system is the most straightforward illustration of this. But there is still no clear response to the query: why does Venus light more brightly than the majority of the brightest stars that we are aware of? Why are planets brighter than stars, and why? The most crucial question is how we define and measure the brightness of cosmic objects. What aspects of cosmic objects, such as stars and planets, influence their brightness? The most crucial factor affecting an object's brightness is its distance from our reference frame in space. This explains why distant stars appear so faint in comparison to planets. Venus and Jupiter are two planets that are relatively near to our frame of reference. They therefore appear more brilliant than the night sky's brightest stars. But if the sole factor were distance, we wouldn't be doing a video about this subject. The brightness of stars and planets individually depends on a wide range of variables. One needs a thorough understanding of complex cosmological words like brightness, luminosity, intensity, and many others to understand the answers to all of our queries. We will make an effort to keep complexity to a minimum and to maximize your knowledge in this video. As the factors determining the brightness of stars do not always determine the brightness of planets, let's first talk about the factors determining the brightness of stars. There are two ways to gauge a star's brilliance and magnitude. Absolute brightness and apparent magnitude are the two measurement techniques. Using photometry, apparent brightness is determined. It is known as the apparent brightness of an object when the brightness is measured by an observer on Earth while the celestial object being observed is at its farthest distance from the Earth. The ratio of the apparent brightness of a celestial object to the brightness of the Sun is calculated as the negative logarithmic value. The more the apparent magnitude of brightness of the star is, the fainter the star is, and the less the value, the brighter the object seems, as we take measurements in the negative. For instance, Venus has an apparent magnitude of roughly -6 when it is brightest and -4 when it is closest to the Earth. Sirius, the brightest star, has an apparent magnitude of roughly -1, on the other hand. The apparent magnitude of nighttime stars is between +5 and +4. The apparent magnitude of the celestial object at a distance of 10 parsec, or 32.60 light years, is the absolute magnitude of brightness. Absolute magnitude calculations are substantially more precise than those using perceived brightness. For any object, including the sun, other stars, and the moon, the brightness may be estimated. The apparent brightness varies with the body's distance from the reference frame. In contrast to absolute magnitude, calculating the apparent magnitude of celestial objects allows for a rough comparison of their brightness as viewed from Earth, but it does not allow for a comparison of the brightness of different celestial objects. The brilliance of a star and its distance from Earth both affect how bright it appears to be. Therefore, when comparing the brightness of distinct objects, it would be appropriate to use absolute magnitude. The total energy emitted by a body also has an impact on the brightness of celestial objects. Here, luminosity is put to use in assessing the brightness of heavenly objects. It is well known that a star appears brighter the more energy and light it produces. When calculating how much energy is being radiated, luminosity is used. Both visible radiation and all other types of radiation, including invisible radiation, are taken into account when calculating luminosity in two different ways. The amount of electromagnetic energy emitted by a body overall per unit of time is measured as luminosity. It is a quantity that changes with distance. Using a tool called a bolometer, the electromagnetic energy emitted by stars and all forms of radiation is computed throughout time, and the most precise measurement is taken to ascertain the luminosity of the cosmological object being taken into account. Simply enough, luminosity determines how luminous heavenly objects are. Like our sun, stars also emit heat and light into space. However, as we all know, a star's brightness ultimately relies on how far away it is from the reference frame. The intensity of a celestial object determines how much of its radiation reaches us. Power radiated or reflected by a celestial object per unit area is known as intensity or energy flux. The most crucial phrase in space astronomy is used to describe how brilliant celestial objects are measured. In terms of mathematics, intensity is directly related to body luminosity and inversely proportional to the square of the distance of the object from the reference frame. As a result, an object's light intensity increases with rising luminosity and decreases with increasing distance. Keep in mind the distinction between intensity and brightness. While intensity depends on distance, luminosity depends on time. Red supergiants and other dying stars radiate more energy than typical main sequence stars, making them appear brighter than other stars. The brightness of stars is determined by the sum of three variables: luminosity, intensity, and magnitude. The brightness of planets, on the other hand, is determined by a combination of atmospheric elements, distance from the observer's frame of reference, planet size, distance from the sun, and visibility owing to the sun's interference in observations. Mercury, not Venus, is the planet that is closest to Earth, despite the fact that Venus appears to be brighter than every other planet in the solar system. Mercury would have lightened the sky more than the moon does if distance were the only factor determining brightness. The thickness of the planet's atmosphere is the main factor determining the brightness of planets as seen from Earth. The amount of light that a planet will reflect depends on the makeup of its atmosphere. Radiation is generally well reflected by carbon dioxide. In general, planets like Venus and Jupiter that have extensive atmospheres of carbon dioxide tend to reflect more than 60% of the sun's incoming visible radiation. Saturn likewise reflects more than half of incoming radiation, but because of its distance from Jupiter and Venus, it is not as luminous as those two planets. As a result, compared to other planets, Venus and Jupiter tend to appear brighter. Due to its thin atmosphere, Mercury typically reflects only 10% of incoming radiation. The distance of a planet from the Sun also affects its brightness. Because they get more incoming radiation than other planets, planets closest to the Sun tend to seem brighter than other planets. When comparing on the basis of distance from the Sun, intensity becomes a determining factor. Venus, for instance, is 8 times as near to the Sun as Jupiter. Venus is therefore twice as bright as Jupiter because Venus reflects energy at a far higher intensity back to us. Due to its lack of an atmosphere, the moon is a poor light reflector, yet because of how close it is to Earth, it still seems brighter than Venus and Jupiter. A planet's size affects how much radiation it reflects, too. Larger planets often receive more power than smaller planets since they have a larger surface area. However, the amount of light that we receive from celestial bodies is inversely related to their square of distance. Therefore, when the planet's distance from our frame of reference grows, its brightness decreases substantially more quickly than usual. The vast distance between Earth and other stars in the universe, however, makes planets look brighter than stars. The radiation emitted by stars is much greater than the radiation that Venus reflects. The vast distance between us and the stars just causes the radiation and its intensity to diffuse across the cosmos before it even reaches us. Even Proxima Centauri, the star that is nearest to Earth, is located more than 4 light years away. Our night sky wouldn't exist if stars weren't at different distances from one another, and Venus' brilliance would have been negligible in comparison to other stars. So keep this movie in mind the next time you witness the brightness of planets like Venus in the night sky. What do you think of these planets being brighter than stars and occasionally even appearing to be stars? Share the video with your friends and let us know what you think in the comments section down below.